Right, so let's start. But I think, as you pointed out, Lori, I think the point of these sessions is to actually have users or whoever joins actually have opportunity to ask any mostly HDF related question, but I'm open answering all the other questions. And so if there is no such a thing, then let's start with the main program as announced. And anyone can stop me with any question, obviously, when they want. So share my screen. What am I sharing? Let me find it. No, I think this is the one. Okay, hopefully people see it. All right. So today I was planning to talk about main talk point would be about fsspec, which is the file system interfaces for Python. It's a project, and for some time I've been using it, but I thought it would be interesting to talk about some other, just mention some other features. But like in many shows, I'll first start with something else so that the main act comes later. So first, I was thinking to go through current selection of h5py issues and pull requests, and then come back to fsspec. So okay, I see from Ben. Okay, well, there is a attendee who has an issue. All right, so Ben, the floor is yours.
Hi, Aleksander. Hey,
hello.
Yeah, I just posted this. I'm having some problems with using object references that are in an H5 file on AWS, and I'm trying to use fsspec to stream that file, which is mostly working great. I can sort of lazily read the object and parts of the file, but there are some object references in one part of the file which sort of refer to another part of the file. And when I go to use those, they read much more data than is necessary, as far as I can tell. So they seem to get the region they point to and sort of nearby regions, and read everything, even when I only want to get a little bit of data from that region. So I'm sort of I'm wondering if there's something I'm doing wrong. It would be much better just to be able to get the name, the location of the reference. So in that dict there, URL to actual location, that's what I'd like to get from the reference. And then I would just be able to use that directly rather than dereferencing the object reference. So if I just walk you through it, there's a small H5 file which is just quick to open and to test this out with, and then I just and the big one is sort of 500 gigabytes in size, and that's the typical sort of file size that I'm working with where this becomes a problem. But yeah, so we open up the file with h5py, and this is those locations there. That's what I'm trying to get out, really. Or that's where the object reference points to for the small h5 file. That's the directory in the h5 file. And then this is just a series of steps through timing and looking at the memory delta for each step. And initially, so number one is just using that location, the location that I already found. If I just use it directly, I can go and grab the data there, and get the name, say, as just an example of getting some data from it. And that's all I'd like to do, really. And that is very fast in number one.
So just to ask you one, sorry. So this one would be a name of a HDF5 dataset in the file or something else? Do you know?
Yeah, it's a data set. Yeah, that's
Okay.
so
All right.
that's where
Okay.
the object reference that we're going to get actually points to that place.
Okay. All right.
So that's
Oh.
using that location directly, which is fast.
Mm-hmm. Mm-hmm.
This is using the object reference itself, and initially you get back this sort of lazy object which doesn't read anything at all. And this, so number two is fast as well. Then I tried these two methods, so 3' and 3 are both sort of using the object reference to try to get some data. And
Mm-hmm.
I thought get name might give me what I wanted, just to get the location. And then that was actually slow, unfortunately. And then 3 is, oh, that's a mistake there. There should be another 3''. You can see that takes 15 seconds to read
Mm-hmm.
a whole load of data. And if we, number 4 is actually showing that when you then go to read something else, which is not the same object reference, the data already seems to be cached. So the initial dereferencing seemed to read everything that was required for number 4 as well. And this is what makes me think that it's reading more than is necessary.
All right. So here are some thoughts right away. So interesting that you're using HTTPS, so to speak, how to call it, HTTPS file
Yeah.
system implementation, although you keep it in S3. You're not using S3.
Yeah.
Is there a reason for it?
No, this is just the address of this file. I think I can convert it to the AWS and actually use an S3 file system. Like I've done that before, and I get the same behavior.
No, sure. It was interesting because typically by the URL, this is in S3 bucket somewhere. Is it
Yeah,
not?
yeah.
And so typically, when people do access HDF5 files and S3 objects, they use a companion package to fsspec that's called S3FS.
Yeah.
I don't think that this is a big change for you, but just sort of interesting point. And this is the first time I see this approach, so I wanted to mention it. So, couple of things I think that come to mind. So this is just an HDF5 file that you brought from Summer into S3, right?
Yeah, exactly. Yeah.
Okay. So the overall issue that you're seeing, I think, is this. So since I mentioned the S3 for others, so fsspec is kind of the umbrella project that gives certain functionality, and then when needed a specific remote backend store, then there are other packages that sort of fsspec relies on. So in this case, for example, if you wanted to work with the LWS S3, you would also need to install S3FS. In this case, for example, here, what is being used is more of a typical HTTPS kind of remote store, which, for example, you could apply to having just a web server somewhere configured to serve you files. But anyway, just to give you some picture how fsspec operates. So, so coming back to your issue, I think that this is a problem of any HDF5 file that just moved into it, that it's not cloud optimized.
Yeah.
I've been talking about this for about a year or so. Essentially, the default behavior of HDF5 library when generating these files is that you are going to be in some kind of a file system. And so making frequent reads of even small amount of bytes is perfectly okay.
Yeah.
And that approach and the philosophy fails miserably when you move that file into something like S3, where, you know, a single read request is, you know, a tens of milliseconds at best, just to set up the connection, to everything, and then you say, oh, give me 16 bytes. That's like, you know, completely no. And I think that in general, this is what, that's the reason why. The whole point of this cloud optimized HDF5 thing is that you actually, either when you're creating this file or once it's created, there are some things that you could do with h5 repack that you could actually help you with these kind of things. And one of the things that can help is consolidating all this internal metadata that you are trying to read and that takes up time into one memory, one block in the file, and then and then telling the library to get you that block of bytes in to bring it over, and so you never again have to spend time asking for little bits of data. Where is something in the file, for example?
Is that another program?
Well, again, if you're already dealing with created file, then it's a tool that comes with the library called h5 repack.
Okay. Okay.
Actually, if I can find this.
Is that a separate option on h5 repack, or does it just happen automatically if you repack the file?
No, you have to tell it. So
Okay.
I actually had a poster about this in December at one of the American Geophysical Union conference, and essentially I don't want to go through this. This is not about this, but since the discussion is talking, this is the kind of thing that you want to run. But then when you do that, you have to tell the library right now, and hopefully Dana, this is hopefully be available in some future library versions, that actually the library will configure itself by seeing these kind of files to actually support this almost basically automatically, that you don't have to tell the library ahead of time. But anyway, I will drop this link to the file. I don't know how these links are shown after this meeting. We have to figure out a way that these links appear somehow in the recording. But as far as the
they should be, I'll put them in the description of the video.
Okay, so this is the PDF to the file, and this is fairly new as far as recommending these things. So I don't have really experiences of people how this actually worked. So absolutely would welcome you contacting me later and telling me, you know, this or that. But generally speaking, I think this is what you're seeing.
Okay.
Now, oh, let me see now. Yes. So yes. So it should approve. However, since you're using fsspec, you also have to be aware, and that's part of what I would talk anyway, but you brought it up. When you do this cache, and in generally how fsspec operates, when you combine it with the HDF5 library, there is a little bit of disconnect between the library operations and what fsspec does, and this is what I mean. fsspec is designed for many other data formats that are kind of sequentially progress through the file as they're reading the data. The HDF5 library is kind of random. You could go forward, backward, that kind of stuff all over the file. You don't have to, but it can happen. And so the fsspec by default has a block size that will always going to read, no matter how many bytes the HDF5 library actually needs. And that default size is 5 MB. So if you actually enabled logging in fsspec, my guess would be that you would see that even the library said, I need somewhere in the file, 16 bytes or 289 bytes. The fsspec would read from that location in the file 5 MB. Anyway.
Mm-hmm.
And so that's another kind of extra work. And then those bytes come and kind of no one needs it. Because the type of caching that you selected is just the first block of bytes on read. In other words, from the beginning of the file, 5 MB, and that's it. So I will try to download this big one. I think I have enough space on my, or maybe not, 500 gigabytes. That's not going to work. No, I don't have that much. Sorry, correction. I just, talking live and thinking is kind of, two separate things. Anyway, so I don't have that much space, but I can tell you if you have that file somewhere locally that you could run some command to give me some information.
Oh, okay. I might be able to do that.
Yeah, because it can give some ideas. But anyway, so that's, I think, the reason why. And the reason why you're seeing speed up somewhere is maybe that, again, whatever it was brought already in as bytes in fsspec caching or something, there is this information that the library needs, and now it doesn't need to make any more requests.
Right.
So that would I say, not saying that maybe there is some slowdown by reading references and that kind of things, but I think just by collecting what's in the file and where is it, it takes more requests than it's really recommended in this kind of cloud object stores.
Okay. There was so underneath I put a link to the HDF5 API, which I just discovered, and the get name seemed in the PyX file seemed to be using get name rather than get name string, and I didn't see the source code for it, but I was wondering why it doesn't use get name string.
But there is another one besides get name. There is a get name string or something.
Yeah, at the link underneath, and
that one.
Seems to do, yeah, exactly. It seems they do slightly different things.
Oh, I see. I see.
So that one said retrieves the name. Anyway, it's okay. Thanks a lot for.
I can tell you in h5py this was put in probably very early on in h5py's development, and depending when this other one became available in the HDF5 library API, probably no one came along, updated for any reason, that kind of stuff.
Right.
I had some experience, not with 500 gigabyte files, but I had some files that doing this cloud optimization thing that I was talking about, it was, 600 times, 150 times faster,
Okay.
that kind of stuff. Just because, again, you just make one request, everything that comes back is cached by the library, and never again you go back for that kind of information.
Yeah.
Well,
I could potentially just download that 500 gigabyte file, repack it, and then upload it again to S3 somewhere and see if it helps.
And then we could see, if it helps. Yeah. Other thing, I would definitely suggest you go to 1.14.3 because it has something that also helps as opposed to 1.14.2.
Okay.
And so those are my recommendations. But yes, I'll answer in your place here. I'll give you some instructions, what kind of thing you could run on this thing, and then we'll see how it goes.
Awesome. Thanks very much.
But excellent. Thanks for bringing this here. It's a great thing.
Oh, thank you. I really appreciate you doing this clinic.
Oh, yeah. They told us, we want to work with the already submitted questions to avoid surprises, but this way I like it. Yeah. I like it. Yes. No, it's great. So let's, because of time, let's jump, let's not go through the h5py too many things. I just wanted to bring another one from today. They actually, I got pinged by earlier today, and it is someone who basically has a master HDF file, and then the bytes of this data set that actually are in a separate, purely binary file, in an external file. And they were reporting when they were reading the data through h5py that they were getting zeros when they were not expecting zeros in it. And then, and I, an hour ago, I kind of said, I just reported what h5dump says about this master file, and this is essentially, as you can see, it's a data set with unlimited first dimension, and it's kind of the bytes are actually in this file. And my suspicion is that I'm surprised. Well, maybe it's not right, maybe it's not wrong, but this value is, as I say, means h5 unlimited, which may be right or not. But anyway, the zeros that are reported may be coming from essentially default field value, because if it's not set, the library assumes it's a zero. So, but let's see, but maybe, the library somehow doesn't handle this thing, or there's some bug in the library. But anyway, this is also from today. So that's that. Coming back to fsspec, which I think is the main. Is anyone has any questions or comments about all of this? Please jump in. Don't make me to stop. No one? So yeah, so I think we kind of covered the most important feature of fsspec, and that is that it really tries to present various number of remote backend storage systems and as kind of through a unified file system-like experience. And what that means, it means that it supports copy, remove, cat, make directory, those kind of things, if it's possible, obviously, to specific remote system. And then on top of that, you sort of opens the file, for example, like what you did in this example, and then allows you to work with that file on some remote backend storage. And I don't know where it is now. That's background. Structure of the package may be helpful, but no. Let's see. So the usage. There was something, the list, and I want to find it. So I apologize for quickly going through it. I'm hoping that somewhere is description of this. Nah. There was, and I saw it somewhere, and I can't find it where it is now. There was a list of all these remote stores. It's quite extensive, actually. Obviously, the major ones, the S3 in Amazon, the Google Cloud Storage, the Azure. There is other one, the Chinese providers also. But basically, it provides all these things, capability. There is a zip, for example, file that you could use for read from zip archives, that kind of things. And obviously supports, oh, there you go. Maybe this is the built-in implementations. I don't know. Yes, so PyArrow, Hadoop file system, about Dask worker file system, Databricks, all this kind of FTP, Git file system, HTTP, and those kinds of things. All of these things are basically now, but for each one of them, you actually need a specific package. Also, it doesn't come everything bundled into a fsspec. So that's fsspec. The other part of fsspec that's interesting is the caching capabilities, and this is what you use. Let's see if I can find somewhere, and I saw it again where it is. Instance caching. So there are several ways how to cache. I'm trying to find where is this. I think it's in API references. maybe block cache. Want to find them. I have to say that as far as the documentation, I'm not successfully managing and navigating these things. Could have been a bit more intuitive, at least for me. So, but anyway, here we are. So this is an interesting part. So basically, on top of all these access capabilities, it does provide a number of different caches that you could use. So for example, you use the one that says first chunk cache. Now, chunk in HDF5 land is a very specific term, but here, what this means is really the first block of the file, from the beginning of the file, and this is what you select. But there are others that can be used, and for example, the one that I think is what maybe work better is this block cache, where essentially every block of byte is kept in a cache, and it knows from where it begins and where it ends. And it's also entered into the LRU type, see the LRU type of cache internally, so that there is some cleanup if that particular block is not accessed again, but they're kept for more. So all these things could be helpful and help to increase the performance. But again, they're the non-supported things. Okay, but the point being is again that this block size. See, this is where some kind of synchronization with the library needs to happen. fsspec will always going to request a block size of bytes, and so in your case you use just the first block and nothing else. If you try to play with the block cache, it may help you more, but it really is not going to change the fundamental problem with your file, that the internal metadata is sort of in many places in the file in very small amount.
So can I ask a question about this? You talked
Go
about
ahead.
you talked about using repack to fix that. Is there a tool that lets us see how fractured the metadata is?
I'm not aware of that. No.
Okay.
I
The
don't think
only
so, no.
So we just
Yeah.
have to hope that repack is doing something useful.
well, hope is yes, but
Yeah.
we can make some informed cases. For example, there is a tool called h5py that will give you the total amount of internal file metadata in bytes, and then you can use that number to sort of say how much you want to allocate for that block of internal file metadata in the repack file.
Oh, okay.
And so that will do the right thing. But again, I would really recommend that this is one of the times that you really want to follow the latest HDF5 library releases, because there are some bug fixes specific to netcdf4 files and this kind of things that h5 repack made in the past on the previous version. So it's really the time to again follow the latest HDF5 releases if you have not been that much in the past years.
Now, my impression is that this control over the metadata area size can also be done by the application itself before it writes the file. Is that what I'm getting from this?
Yes. If you're in a
Okay.
position to create file now, you can configure the library to do these things.
And
Yes.
and would we need the latest library for that, or were these bug fixes just in the H5 repack application?
So the latest library applies to h5 repack and applies to reading the data from something like this, or
Okay.
accessing the file already created.
So
For
we've had things
creating
like aggregation in the library for a long time. So you just have to set up the how you allocate metadata on the disk and the property list settings.
Okay.
I would say that as far as creating 110.1, 110.2, maybe some of these 110s.
I think you have to use 110.2 because the original implementation of paged allocation had like a problem, and so they actually broke binary compatibility when they released 1.10.2, if I remember correctly. It's a long time ago.
All
But the
right.
1.10
Yeah.
series, if you're in a recent version of 1.10, you should have those abilities.
Right. I mean, our application here is in processing remote sensing data, satellite remote sensing data. So we process, you know, thousands and thousands of files for almost an individual system. It would be nice just to have the application get it right before the file is written, then have to go back and run
Right.
run H5 repack as a post-processing step. So,
Right. Which version are you on?
and which group?
But no, which version of the library are we
Oh,
using?
You know, I don't know. I'd have to look.
I mean, I would highly recommend staying with like moving to 1.14 if you have not, because we've been making a lot of improvements there. So it's definitely worth upgrading.
Okay.
I think that what you were talking about with 1.10 happened between 1.10.3 and 1.10.5. So you
Alright.
should use 1.10.5 or later.
Okay.
And the last one was 1.10.11. But 1.14 would be
Much
probably a
better
better
choice.
choice.
You even have a Hugging Face hub file system, you know, capability here. So it's very useful. It's very useful and very interesting project, really. And this is the S3FS that I mentioned for Amazon S3. What I want to say. Yeah, by the way, satellite data, I mean, all of this work that I'm talking about really came out of me working with NASA Earth Science data. And so this is very much from all that work, actually. I haven't been able to reach to other communities so far, but they are actually quite reporting. I mean, I'm witnessing and I'm seeing other people telling me that this is really making an impactful change. But again, you either have to create a file or you have to do it repack. So it's kind of, for millions and millions of NASA Earth Science data files in HDF5, it's kind of like oopsie. So that question, how to go back and do these things, is now also something that we'll have to see how it plays out. And there are other aspects of also cloud optimized files. We're just talking about internal file metadata. The other one is also the chunk size. And I've seen some NASA, and I had the previous 2 months ago, I think I had called a doctor session about JEDI. It's a LiDAR type instrument on the International Space Station, and I was seeing data set with one element or just one element as a chunk shape, like 4 bytes or 8 bytes as a chunk size. That just cannot be. I mean, and so those kind of things. Anyway, so why this fsspec? I just want to, because it's taking time. So why is fsspec actually working like this through h5py with the library? Well, the reason is because HDF5 library has this thing called virtual file layer API. So it's not virtual file driver, it's a virtual file layer. Why did these two names are so similar? I don't know. But yeah, the layer is the differentiator. And I think about 5 years ago, software engineer called Andrei Paramonov essentially connected this virtual file layer with Python file-like objects for h5py. And basically, since then, if you provided any kind of Python object that had the same methods and any file object in Python would be required to have, the library would be happily able to work with that Python object. And this is essentially the connection that enables also fsspec to work. And to give you an example of how simple that is, I had a notebook some years ago, again about TerraFusion HDF5 files that speaking about connection to NCSA. yeah, that was a Terra Fusion file, which was from satellite data in S3. And I provided an example with fsspec, but I also wanted to show how you could create your own. And this is just for the example. This is the class that I created that implements all the required methods that make it work through h5py with the library. And basically, you need to have readable, seekable, and you have to set them to true. The size, tell, seek, and read, and then also read into. And once you, however you implement them, that's up to the implementation. But these are the methods that needs to exist. And once you do them, you're good to go. And just why this file is slow, here is the example. One of the reasons I wanted to have this class is because I wanted to print out every single request that library makes to S3. And this is exactly what you get. Just on the opening file, the library will make these many requests to the file sequentially for 8 bytes, then 16 bytes, then 80 bytes, then 512 bytes, and then going through the file at so the end of the file for these many things. That just, that is really, really a big problem for cloud native computing. You just cannot make that many HTTP based requests for this little amount of bytes. Now, why I'm saying 1.14.3 should be used for reading data is because Dana was actually the person who implemented, I think, that now all of these requests in the first 16 megabytes of the file would be brought into, if you're using Raspberry VFD. I'm not sure about the fsspec. No, but yes, it's only if you use Raspberry VFD, but not fsspec. But anyway, so these things will not happen anymore like this.
And is the wide distribution of source locations due to the fracturing of the metadata in the file?
Well, to some degree, this is, way back library thought I'm in a file system, so who cares if I make this little number of requests? But the distribution is kind of, the only way that you prevent this spreading is that you'd have to tell the library that you want to have this. You either have to set it up that your metadata block is of large size, or that you have this page allocation file space strategy.
Right.
The poster talks about this thing, but that's the only way you can prevent this. If you don't do that, the library just continue to shoot internal metadata wherever throughout the file.
Right. Right.
I mean, it's not that the library is doing the bad job. It's just that the library is not told, hey, this is really important, do it differently. But other than that, the library thinks, oh, you enjoy me spreading metadata throughout the file because, I'm doing things, writing them out only when I know that they are safe to write out, that kind of stuff.
Well, a lot of this is like, these were decisions that were made back in 1997, and they're not appropriate for 2024. And one of the things we want to do in a future release is revisit all the library defaults and change them so that they work more appropriately for modern IO systems.
Yeah, I'm beginning to realize that in some other aspects. Yeah, for our remote sensing data, a particular file type is virtually identical across an entire mission. It's but roughly the same size. It has all the same data sets, and so if we are able to fix the metadata size properly for that, once, then we'll have it done for the whole mission.
Yep.
So this is the talk I gave the conference in July last year. That talks, I think, first 20-some minutes, 22 minutes is me talking about cloud optimization strategies. So I highly recommend to look at it. And this is sort of like a spoken explanation to my to my poster that I did in December. So it has more sort of explanation how you can go about optimizing this file. And so I think it'll be helpful as well for this. But anyway, coming back to fsspec, Yeah, I think it's great. I think that, again, these are the 4 cases where really the files or data is in some kind of remote storage that will not give you the performance, obviously, that compares to anything local or, you know, especially not in some kind of supercomputing system. But if the data is too big or some other reasons why people prefer them to be there, I think fsspec really opens up, and especially because in this way, it really gives you an option of this backend storage system without really requiring HDF5 library to come with all this support. The only glitch now is, as I mentioned earlier, this block size impedance mismatch, if you want, like a mismatch, because the library knows exactly from where and how many bytes it wants in the file, and then you have the fsspec that says, well, I'm only doing my request in block size. And so right now, I'm not quite clear how you can, ahead of the time, unless you really know your files and you know how they're created, obviously, then you can tell to fsspec, I know that I can make the library number of bytes and your block size really work hand in hand, like really are in sync. Now that's the best approach. And also, use one of these caches like block cache that really will keep more blocks cached than you know, just keep them around, keep them on the client side. And not to mention, because I didn't talk about really what the library can do, but one in these kind of modes where you actually tell it that the file is cloud optimized and that there is this specific things, then the library also opens up another layer of caching by the library itself. So now you have layers of caches, starting from the chunk cache, which always was there in the library, then this page buffer cache that becomes available, then you have fsspec that caches. Ooh, you know, like 3 layers of caching, you know, like that's like 3 PhD theses in supercomputing. You know, at least, you know, who caches when what. And so anyway, that's all really. I spoke more than I expected, but are there any questions, or I skipped something, or people got confused with something? Because obviously kind of worked from backwards rather than forward, but that's how it happens.
Aleksander, I just have one question. If you use repack and cloud optimize your file, are there any unintended consequences if you were to take that file and now bring it back locally and access it locally? Do you incur any inefficiencies if you were to do that? Or are there any unintended consequences of a repack like that?
I would assume that I don't have any data to support this, but I would assume that cloud optimized HDF5 is also optimized for more modern IO, like just for file systems.
Okay, so it would really help you if you did it properly on both sides. It's so there wouldn't really be any downside to having a properly cloud optimized.
Yeah, one of the things I want to investigate over the next year or so is, should we just make essentially what we have, what works well for cloud optimized HDF5, just essentially the library default.
I see.
Right, because I mean, it makes all the metadata local, right, which is nice.
So here is, I'm open up the page that I actually did some benchmarking recently. These are the JEDI files that I mentioned, this LiDAR-like instrument on the International Space Station, and I actually created versions of this file with different. Here is the actual command line, for example, that I was repack that I was using, and I created version of this file, and I then accessed all of them from S3, and then I accessed them also in a local file system. This is EC2 instance in the Amazon cloud. And long story short, let me just bring to the graph that so the question was locally comparing. Let's see, I think it's further down somewhere. There we go. So I'm comparing the files Cloud optimized, in other words, with this called pages, file pages, and these are the size of these file pages, different sizes of file pages, and I'm comparing with the original file, which was created, as with default library setting. And so there is some impact, as you can see. It's sort of plus minus 5%, but there is some impact in between. With the original file. So the point being here is that the original is better if it's above 1. So every dot that's above 1, that means the original file was better. But there are some cases, for example, where the cloud optimized was better also in a local file system. So, and these tasks are some specific data reading patterns, again, typical for this type of file for something. So, but anyway, that's what I want to show you. So, there is something, but again, I think the other problem or the benefit is that then you have a file that kind of is not going to really work badly in the cloud. And that's what the whole point of cloud optimized file was, kind of like, can we find some middle ground that really opens up the possibility of accessing these files in the cloud and doesn't really kill anyone who actually wants to download those files or something like that.
But also too, like, so when we look at this and we see some stuff that, where the original is better, are there changes that we can make to the library to flip that, right? That given cloud optimized files, should we adapt the library to that new reality and then make it faster?
Oh, sure. Yeah. All I was doing here is what's currently available. Currently,
Right.
as in the up to the latest.
Right.
Not what could have happened, or can happen. Yes. So
it looks good that, like, in general, we're seeing, basically parity or slightly better for, even with a cache that's optimized, like several caching layers that are optimized for essentially 1997 data access patterns.
Yeah.
And sizes. All right, I have to bounce to another meeting.
Okay.
Great talk. See you guys.
Alexander, I had one other question. When you were when you're on the pages that were referring to built-in implementations, I think it was, there was a reference to HDF5 on that page. I wasn't clear where that fit in. It was on fsspec, and I think it was.
Yeah, no. Did I close down that page with? I did. Oh my goodness. All right. So you saw this. So okay.
I think it was on built-in implementations. If you go on that left-hand column.
Yeah, we'll see. Let's see. Well, this one? No. Oh, further before.
No.
Yeah,
that
okay,
was you're under
see.
other known implementations.
Okay.
Yeah, if you go all the way down, there's an HDF. There was something that referenced HDF5.
It's HDFS. I think it's Hadoop.
Oh, that's HDFS. Oh, I'm sorry. Okay,
yeah.
I got to run a bigger font. Okay, all right. And the final question I had just was, any counterpart to this if you're using a native C interface to HDF5? Is there any relevance there? Because I understand this is pure Python. This is only for the Python side of the
yes.
world.
Yes.
So
I'm not aware of.
It would be nice to have it in the native C world as well, but I don't know. Maybe that's just not possible.
I don't think it's not possible. I would say it's not as easy as creating it in Python. So that's one. Because what you really, I have to mention here, obviously, there is the read-only S3 virtual file driver that is part of the HDF5 library.
Right, and I wondered how this fit in with something like that, because the scope of this is obviously much bigger.
Well, so fsspec is a sort of at the level of ROS3 VFD. In terms of functionality, the ROS3 VFD would allow you to read an HDF5 file in any S3 compatible store.
Yes.
fsspec gives you that, but so but through a kind of a different doorway, which is this virtual file layer API, whereas ROS3 is the proper virtual file driver in the library. But library currently has none support of all of these other things. And I would assume that making support for this through the library would be, quite monumental task. So for the other languages that are not Python, that's a very good question. I think, obviously they should target in their interfaces to HDF5 library. They should probably think about introducing virtual file layer, connecting that, and hopefully then in those languages you can connect with the library that way. I heard some talk, but not recent much, that there were some discussions that fsspec should be rewritten in Rust programming language. There are now some success stories of Python tooling being written in Rust. Like there is one, pandas. Pandas is a big thing in Python, scientific Python, about tabular data. There is one implementation called Polars, which is in Rust, very fast, very good things about it. There is one linter for Python code called RAF that also is super fast. And so there is this kind of talk I heard that maybe fsspec, because of its utility, should be written in Rust, but then I haven't heard anything else, so who knows.
But if you're trying to make some data source look like a file system, at least under Linux, there's the Fuse file systems.
Yeah.
Which then any application can treat the data source just like a file system.
Right.
Now, of course, if
So,
you're on Windows, that may not work so well for you. I don't know if that's available.
yeah. So that's all I have. I will.
Can I ask an unrelated question or a marginally related
Yes.
question?
No, yes.
Okay. In our application, I guess maybe it's unjustified, but I have kind of a personal preference to writing our production codes in compiled languages, statically linked compiled languages, so they can be sent off to various nodes to do the data processing without worrying about the dynamic linking aspect of it. So far, that's meant for us doing things in either C or Fortran because we're very heavy users of HDF5. Is there, but C is kind of no longer really recommended because it's not very memory safe and you wind up with a lot of bugs due to buffer overruns. Is there any recommended other language that works well with HDF5 that has a decent interface that people are using?
I don't know.
Okay.
To be honest.
Right.
Are you referring to the White House memo, recent one or something?
Well, I have long wanted this, and then a colleague of mine pointed out that the both NIST and National Security Agency have suggested that C is not really appropriate for writing safe code. So I was hoping maybe that would would encourage funding for for interfaces to other languages. And I was just curious to know if you had any idea or experience with maybe not what you use yourself, but what other groups are doing.
There is a crate in Rust for H5.
Yes,
but it doesn't look as well used as h5py. So
right, that's I look at the updates and see what has been updated in the last 3 years. If not, maybe it's not very not very heavily used. Okay, maybe I'll post it on the forum then and see if anybody has a suggestion there.
So are you looking for? So because again, Rust, as far as I know, that crate is also just like h5py, just pass through to the HDF5 library.
Yeah, that's fine if it passes through. It's really
okay.
I'm not worried about the safety of the HDF5 library. I'm assuming that the testing procedures done at the HDF group are catching most of those problems. It's really in our own codes that don't get exercised nearly as heavily as the HDF5 library. That and I'm less worried, I think, about code safety than I am about just having bugs and having things crash, 2 years after we, implemented them because we were hitting a corner case that we had not encountered before. So that's really the problem I'm trying to solve. But okay, I'll probably, I know there was something for, what was it, Golang, I think, but I don't know, it doesn't look like it was that heavily used. And so I'm trying to figure out if there's something that's actually being used out there. And I guess I'll just post something on the forum when I get a chance and see if anyone has a suggestion. Yeah. Well, thank you.
No worries. You're welcome. Ben, I will answer on this issue in h5py repo, and then we'll take it from there.
Thanks a lot.
No worries. Thanks for it. Actually went better than I expected. Actually, yeah. It was the real live session, which is always fun. Yeah. Thank you.
Thanks for hosting this. Cheers.
Yeah, no worries.
Good day.
Bye, everyone.